Hello everyone and good morning. We are going to be starting a new module today and this week, which is really exciting. Before break, we were working through module 3, looking at all types of linear equations. And what we're going to do next is look at systems of equations. So a system of equation just means that there's more than one equation, okay? And sometimes these equations will intersect and cross to make like an X. Sometimes they'll never intersect. Sometimes they're just actually the same line. And we're going to use that knowledge to solve a system of equations. So when we're solving a system, we're trying to find, do these lines intersect? And if they do, where? So on the first slide, take a second and put your name in that name box. We're going to specifically look at solving systems first by graphing. So we're going to graph equations and then see if they intersect. Push ahead to slide 2 when you're ready. One of the linear equation forms that we talked about in the last module was slope-intercept form. And this is y equals mx plus b, where m is your slope, it is your rise over run, subtract the y's, divided by subtract the x's, change in y, change in x, all of that is our slope. Then we have our b, which is our y-intercept, where it crosses the y-axis. At that point on the y-axis, our x-coordinate is 0. So we can always plug in 0 for x to solve for that y-intercept. This is just a review about one of the forms that we'll use to graph today. Slide 3. So just warming up our brains, getting back from break, we're just going to take some time to identify the slope, which is m. That's that number, or that's always in front of x. And then b, which is our y-intercept, the number that's added and subtracted on its own. So in this first equation, in front of x, we have a negative 2/3 and a y-intercept of 6. So notice where I'm grabbing that in our equation. For the next one, our slope right in front of x is a 5. So we'd go up 5 over 1, up 5 over 1. And our y-intercept here, we have subtraction, so it's a negative 2. For the next one, our slope is 4/5, up 4 over 5, and our y-intercept is a positive 12. Remember again, that's a point, right? 0, 12. It's where it's crossing the y-axis. Down below, our slope is a negative 9, so it's a negative slope, so it's going down and to the right. And our y-intercept is a positive 1 at 0, 1. Here we just see a minus sign in front of an x, so that's a negative 1. And our y-intercept is a positive 3. Last one, we have a slope of 6, and we don't see a number added or subtracted, so we can think of that as plus 0. So our y-intercept there for that equation is just 0. Once you have all this down, pause if you need to, go at your pace, and when you're ready, push ahead to slide 4. So again, we're just reminding our brain the stuff that we looked at in the last module, refamiliarizing ourselves. Y equals mx plus b. Remember, m is our slope, and b is our y-intercept. So looking at this first equation, I see the y-intercept is at 4, 0, 4. And the slope, we would want to find another point. And remember, we want it to be a point right on the grid line. So like, can I zoom in? Yeah. So here would be a good point. Here, right? Because they're right on crossing on those grid lines. And we can see to go from one point to the next, we are going up 2 and over 1. Up 2 over 1. So our slope is 2. When we're writing our equation, it would be y equals 2x plus 4. Has a slope of 2 and a y-intercept of 4. Looking over to the right, I'm going to zoom in again to get a little closer. Will it let me? Come on. There we go. Our y-intercept is here at 2. So that's our b value. And our slope, we have some points labeled. We can use those points that are labeled. So we're counting how much we're going down. 1, 2, 3, 4, 5, 6, 7, 8. We went down 8 and over 1, 2, 3. Oops. 1, 2, 3, 4. So our slope is a negative 8 over 4, which can be reduced. Negative 8 divided by 4 is a negative 2. So our line for this equation would be a negative 2x plus 2 for our y-intercept. So hopefully this feels good. We did a lot of practice with this, like I said before break in the last module. If you need extra help with this, please reach out to me and we can find some time to do some practice like this together. When you're all set, push to slide 5. So we are going to be solving systems by graphing, so it's going to be important to feel confident with your graphing skills. So here's our equation, y equals 1/3 x minus 2. Identify the slope and the y-intercept. So our slope is 1/3 and our y-intercept is negative 2. Great. Plot the y-intercept. So I'm going to put a dot on our y-axis at negative 2. That point is 0, negative 2. Use my little text tool there. There we go. Use the slope to plot the second point. The slope is rise over run, so we're going to move, it's 1/3, so we're going to go up 1. And then we're going to go the run, and it's positive, so we'll go right 3. This will give us our second point. So from the y-intercept, we're counting up 1 and to the right 3 and put a dot. Then we will draw a line. I'm just going to make this smaller, connecting these points. I always extend my line and I put arrows on the end. Beautiful. There's our first graphed equation. Okay. After you have graphed that, push ahead to slide 6. We'll look at another one. So our slope, our m, is a negative 2/5, and our y-intercept is a positive 2. And I'm just finding those right from the equation. So our y-intercept is at this positive 2, and our slope is negative 2 over 5. So we're going to go down 2 over 5 and put a dot. And then I'm going to use my line tool, connect those points all the way through and put some arrows on the end. And there is our graph. Push ahead for slide 7 when you're ready. We'll do, one more here. So our slope is 3/4 and our y-intercept is 0. There's nothing added or subtracted, so it's just a plus 0. So here's our y-intercept right at 0, 0. With that slope, we are going to go up 3 and then right 4. So from here, we're going up 3, because it's a positive 3, and to the right 4 to find our second point. Then use our line tool to create our graph. Beautiful. So hopefully we feel comfortable again graphing in slope-intercept form. Push ahead to slide 8. Sometimes we will get an equation like we see here where it's not in slope-intercept form. So remember, to be in slope-intercept form, it's y equals mx plus b, right? So y has to be alone on the left side of the equation. So when we're looking here, we have 2x minus 3 times y equals 6. To get this into slope-intercept form, first we want to move this positive 2x to the other side. That's a whole term. We can move it all together because they're attached with multiplication. It is positive, so to move it to the other side, we will just subtract. 2x minus 2x is 0, so we're just left with this negative 3y, bring it down, equals. I'm going to put the negative 2x in front because that's how it is in our slope-intercept form, and then we have a positive 6. So we just connected these two here with addition, and our 2x is negative, 6 is positive. Now we need to get rid of this negative 3. The negative 3 on the outside is attached with multiplication. So to undo multiplication, we will divide by negative 3. And whatever we do to one side, we have to do to the other. So we have y equals negative 2x divided by negative 3. Those negatives will cancel, and we'll just be left with positive 2/3 x. 6 divided by negative 3 is a negative 2. So there's our now equation in slope-intercept form. So we did step 1. Check. Plot the y-intercept. So our y-intercept is right here at negative 2. There we go. Boom. Use the slope to find your second point. Okay, our slope is 2/3, so we're counting from the y-intercept up to over 3 and putting a dot. Check. Now, I'm going to connect these points like so. And there is our graph. Now let's see if you can find 3 pairs of values that make the equation true in the graph of this equation. So what this means is there are points on this graph that will make that equation true. And these grid line points are perfect examples of that. Each of these points will make that equation true. So we have 6, 2. There's one of our points. 3, 0 is another. Our y-intercept of 0, negative 2. Here's another one at negative 3, negative 4. And if we plug these values into the equation, we will get a true statement. Okay? So I'll show you. So if we did 6, 2, for example, 6 is our x, 2 is our y. So in this equation, 2x minus 3y equals 6. We have 2 times x, which is 6, minus 3 times y, which is 2. I'm just plugging in that point, equals 6. 2 times 6 is 12, minus 3 times 2 is 6. And guess what? 12 minus 6 is 6. We get a true statement because it's on the line. Okay? When we have a point on the line, when we plug it in, it will be a true statement. Check out part